Hey everybody, welcome back to the channel. Today I'll walk you through 12 PySpark functions that are less well known but are very useful and can set you apart from the competition. Cube and rollup. Let's say you have a table of products and their sales data in different cities and years, and you want to understand the interplay between them. So you want to know the average sales per product for product A and for product B overall, but also per product and city combined, which are another three groups and a different level of granularity. Combination of two columns instead of one. You can easily group by several levels of granularity using the cube method, with syntax that is basically identical to the regular group by method, since the cube is a generalization of the group by idea. As you can see, the result gives you the average sales per all combinations of values of product and city. The mean across the whole sales column, grouped only by product, grouped only by city, and grouped by all combinations of both, like a regular group by on these two columns. The rollup function is in the middle between cube, which gives you all possible groupings, and group by, which gives you only groups from the smallest level of granularity. It will give you all levels of granularity only for the rightmost column in the array, in this case the product column. So you get the mean for all products, for every product across all cities, and for every product plus city combination, but not for each city across all products. Pivot and melt. Melt is a data wrangling operation that changes the format of a table from wide to long. It allows you to unite two different columns into a single column in the expense of adding new rows. In this example, we want to unite the sales global and sales local columns. After using the melt function, we now have a single column, sale type, where the names of the columns in the original table is now a value. In terms of syntax, unpivot is another name for the melt command. You can use both. The IDs argument lets you specify the columns that will not change. I still want the product, city, and ID columns in the result data frame. The values argument holds the columns you want to unify. And the last two arguments are the names of the two new columns, one for the column that has the original column names as values, and the other for the column that holds the results from the original table. The pivot operation has the inverse function to convert a table from long to wide format. As you can see, by using pivot on the result table, we are back with the original table, apart from the ordering of the columns, with different sales global and sales local columns. In terms of syntax, you need to input the column you want to separate and choose the appropriate aggregate function. In this case, I used first to get back the original table, but others might be a better fit depending on the use case. The pivot function is very useful and can be used for more than just reversing the effect of the melt function. For example, if you group only by city and product and not by ID, and use the mean aggregate function instead of first, you get the mean sales revenue for both the local and global sales for all combinations of city and product. Null safe equality. To demonstrate the idea of null safe equality, we need a different toy dataset, one that contains nulls. Let's add a column that specifies if the values in area 1 and area 2 are the same. Notice that we are using the regular Python equality sign here. Well, we can see that A really does equal A and B does not equal A. So far, so good. But when asked if A equals none, we get none as a result, as if PySpark tells us, I don't know how to answer this question. Furthermore, even comparison between two nulls equals null. Now, let's switch to a null safe equality operator. It does not exist currently as a command of its own, so we have to use it inside an SQL context using the expire function. that lets us use and combine SQL expressions in our code. Now, nulls are treated like any other value. A and null are not equal, and two nulls are. Overlay. You have a sensitive dataset, credit card numbers. You want to hide all digits except for the last 4. One easy way to accomplish that is using the overlay function. It's very simple. You want to mask characters for the credit card number column with this string, starting from some position in the string, which is the first position in this case. Another option, just to demonstrate more capabilities of the overlay function, is to replace some part of the string with a string from another column. This can be done by inputting the mask column at the second argument and changing the start position. There is one more optional argument that tells the function how many characters to replace. And so, even though our masking string is more than 4 positions long, it replaces only 4 characters in the original string, resulting in a longer string overall. Max by. Okay, imagine you want the oldest card number per client. So we want to group by client, identifying the max value for card age for each client, and retrieve not the age itself, but the number that is associated with it. To get just that, we can use the max by aggregate function. We want the credit card number with the max card age, which is exactly what we get. We can get similar result using the min by aggregate function, of course, that will yield the newest card per client. We also added the age here using the min function. Pose explode. You have a database of running competitions with the competition number and the first 3 places as an array. The order of the array is not random. The leftmost person is the first place, the one in the middle is second place, and so on. If you just explode it, you will lose the information on the ordering in the array. But by using pose explode, a combination of the words position and explode, you will get another column with the position in the original array. The syntax is identical to how you would regularly use explode, just replace the word explode with pose explode. Explode outer. Continuing on the subject of exploding, what if you have nulls in the array column which you are exploding? Well, with regular explode, you lose these lines. But with the explode outer command, you can maintain these lines. Array compact. This is another useful array function that takes care of nulls within the array. By using array compact, you can remove the nulls values from the array with ease. Coalesce. Coalesce is a very useful tool for dealing with missing values. In this dataset, we want to use the official first name when possible, and the nickname if we don't have an official name. Well, Coalesce does just that. It takes the official names and resorts to the nicknames as a fallback. Concat with S. Concat WS stands for concatenation with separator. Imagine you have a dataset with address details in different columns: country, city, street, and house number. You can join them into a single address column separated by dots using the concatws function. First, you provide your desired separator, in this case a dot, and then list the columns you want to join using this separator. You can use a regular list, but the star syntax seems more elegant to me. Comb dist. This time your dataset involves sales of different products in different stores, and you want to keep only the highest revenue products at each store to make them more efficient. Well, the first step you need to take is to multiply the number of sales for each product by its price to get its revenue for that store. Then we create a window function, which I assume here that you are generally familiar with, over the stores. Finally, for each store, we use the comdist aggregate function. By doing this, we can get the relative rank of the row within the partition. Let's take store 1 as an example. There are 5 products that are sold in the store, so the values are multiplications of 1 divided by 5, which is 0.2. They are ranked from least revenue to most, as defined in the window function. On the other end, in store 2 there are only 4 products, so the values are multiplication of quarters. The usefulness of this function is that it allows us to identify the best 40% best products in each store, even if the number of products in each store is very different, as opposed to, for example, choosing the best 5. Date diff. Date diff tells you the difference between 2 dates in days. How many dates passed between one and the other. By using it on 2 date columns, we can get the duration of the time range. Another option is to combine it with the current date command to get only the latest records. In this case, those that happened during the last 30 days. Inline. Inline is a very useful function to deal with the struct data type, which is like a Python dictionary with keys and values. Here, our book dataset describes the books and their authors, which there might be several of. For each, there's data on names, age, and whether they are a dog or a cat person. By using the inline command, which only exists as an SQL command currently, which is why it's under the expare command, we can sort of explode the struct into multiple columns, which makes further analysis very easy. Levenshtein. Our last function is the Levenshtein function, which is a neat way of measuring how similar 2 strings are. For example, let's say you want to check your employee emails for mistakes, and for that you compare the full name to the username part of the emails, and all of the emails follow the pattern first name dot last name. First, you lowercase the full name to account for names having capital letters. And then apply the Levenshtein metric that tells you the edit distance between the username and the full name. The higher it is, the more different the strings are. The edit metric tells you the minimum number of additions, subtractions, or substitutions of characters that you need to get from one string to the other. For example, in this case, we need to make 1 subtraction and 1 substitution. So the edit distance is 2. Based on these results, I would say that everything with an edit distance of more than 10 is probably a mistake. Thank you for your time and see you soon. Goodbye.